In this last video covering groups, I'd like to do an example working some computations in a less familiar example of a group. So where I'm going to be working is, I'm going to be working in GL2 of Z mod 26C. Remember what that is. It's the set of 2 by 2 matrices with non-zero determinant, where all of the numbers in a position in the matrix must be non-negative integers strictly less than 26, so numbers 0 through 25 inclusive there. And here's the problem. Let's find the inverse of the matrix 2, 3, 7, 8 inside GL2 of Z mod 26C. And I suppose that, so remember the operation here is multiplication. Again, inside the matrix we're going to have to use modular multiplication since we always want our entries of the matrix to be numbers between 0 and 25. So how are we going to go about doing this? For a 2 by 2 matrix, I'd like to do the following. So if we were working inside the real numbers, I think we'd all be a lot more comfortable. If we were just thinking about 2, 3, 7, 8 as a matrix that had real numbers as entries, we would know how to find the inverse of this matrix. We would use this formula that we're all really familiar with. We'd find the determinant of the matrix, which is AD minus BC, right? If the matrix has entries A, B, C, D reading across the rows there. We'd find the determinant, AD minus BC. We're inside GL2, so this determinant is non-zero. We can divide by it, that's all okay. We'd look at the reciprocal of that determinant, so 1 over AD minus BC, and we would multiply that by the following matrix. We would take the A and the D, and we'd interchange them, and then the B and the C stay put, but they gain this negative sign in front of them, and that's how we go about finding this matrix. So if we were working inside just the real numbers, we'd find the determinant of the matrix, which is 16 minus 21, it's negative 5. We'd switch the 2 and the 8, negate the 3 and the 7, and we would have the inverse by just sort of multiplying everything through by negative 1/5 and sort of doing the right computation. However, we're not going to be able, if we do that, we're going to end up with, for example, the entry in the top left position of the inverse matrix would be negative 2/5, which is not an integer in the range of 0 to 25. And so if we just use this formula in a straightforward manner, we're not going to get the right answer. We're going to get an inverse of this matrix over the real numbers, but not sitting inside the set that we want. This set that we're looking at, GL2 of Z mod 26C, we know that this is a group, and so we should be able to find an inverse for this matrix sitting inside this set, not outside of it. So we're going to go through and we're going to use exactly the same formula. It's just going to be our job to interpret everything that we see and try and figure out what it means in a modulo 26 environment. So here's what I mean by that. Like I said on the previous slide, the first step is look at that 1 over AD minus BC. This is really the puzzling part because we don't have fractions working inside Z mod 26C. So the determinant of the matrix, AD minus BC, is 16 minus 21. So when we look at that piece from our formula, the 1 over AD minus BC, we end up with a negative 1/5, or 1 over negative 5 is how I'm going to choose to look at it here. The first thing I'm going to do, sort of at each step, I'm going to say, that doesn't make sense, mod 26. That doesn't make mod sense 26. And I'm going to try and replace it with something that does make sense, modulo 26. So the first thing that I see that doesn't make sense modulo 26 is this negative 5. I'm looking for a number strictly in between 0 and 25 that is the same as negative 5 modulo 26. So what I have here is that negative 5 is congruent to 21 mod 26. A really good way to think about negative numbers modulo something is to just go up to 26 and start counting backwards. So when I see negative 5 and I try to figure out what it's equal to, modulo 26, what I do is I go to 26 and I count down by 5 numbers. So I say 25, 24, 23, 22, 21. I've counted down by 5 from 26. So negative 5 modulo 26 is the same thing as 21. So the first thing that I can do to try and make more sense of negative 1/5 modulo 26 is to replace the negative 5 by 21. So now at least when I'm looking at 1 over 21, I'm saying at least 1 and 21 are both numbers that make sense to me modulo 26. However, fractions don't make sense modulo 26. We don't necessarily have, we're working with multiplication, nobody said anything about division, and so here's really the proper abstract algebra way to think about 1 over 21. You're really thinking about this as what is 1 divided by 21 is really thinking about what is, remember that 1 is the multiplicative identity of modular multiplication. So we're saying what is the multiplicative inverse of the number 21 when I'm working modulo 26. Now 21 and 26 are relatively prime, so we know that 21 would belong to u of 26. It has a multiplicative inverse. Right? So there is some number that when I multiply it by 21, I get something congruent to 1 mod 26. That is, I get something that's 1 more than a multiple of 26. To see this, let's take a look at the way that we would go about finding this at this point in time in our mathematical career is just trial and error. Try multiplying 21 by all the different things relatively prime to 26 and less than 26 until you hit a match. Here you find it really early. If you take 21 times 5, you get 105. 26 is 1 more than a multiple of 25, so 25 times 4 is going to be 4 more than 100. Nice easy multiple of 25. So 26 times 4 is going to be 104. So 105, which is 21 times 5, is just 1 more than that multiple of 26. That is, 21 times 5 is congruent to 1 modulo 26, and that's our answer. If I'm looking for the multiplicative inverse of 21 modulo 26, which is how I should interpret 1 over 21, then I'm looking for 5, since 5 is the multiplicative inverse of 21 when I'm working mod 26. So stringing that all together, when I take a look at 1 over AD minus BC from that formula, in each step of the way, I need to make the correct interpretations and changes to look at things properly modulo 26, my special modulus here. Once I've figured this part out, the 1 over the determinant part of that formula, the rest of that formula is really straightforward and easy to follow. So following the equation for finding the inverse of the matrix, just working inside of R, I take 5, which is this 1 over AD minus BC, modulo 26, and then I follow the formula. I take the 2 and the 8 and I change their positions. I take the 3 and the 7 and I negate them. Just like we did before, we look at this matrix and we say, something bothers me about this matrix. Negative 3 and negative 7, they're perfectly fine integers, but they're not in this range of 0 to 25. So what I'm going to do now is replace negative 7 and negative 3 in this next step of the equality to here by their counterparts that live in the proper range in between 0 and 25. And I'm going to use my counting down method again. So what's negative 3 mod 26? Well, I'm going to go to 26 and I'm going to count down 3. So 26, starting at 26 and I count down 3, 25, 24, 23. So negative 3 is the same as 23 modulo 26. And if I start at 26 and count down 7, I'll go down the 6 to 20 and I'll go down to 19. Go down one more to 19. Now on the inside of the matrix, here everything is a proper entry in Z mod 26C. And the very last step is distributing that 5 to each of the components here and then reducing modulo 26, which is very straightforward. The easiest of those to verify is that 5 times 2 is 10, because I don't have to do any modular arithmetic at all, so that 10 entry here at least checks out. And the rest of them I'll leave to you as an exercise to verify that this 14, 11, and 17 is actually correct. And this is how I would find the inverse of 2, 3, 7, 8 as it stands inside this set. In summary, after watching this collection of 4 videos, these are the things that I'd really like you to know. I'd really and truly like you to understand the definition of a binary operation and the definition of a group. It's not just important that you memorize these things for the sake of memorization, it's important that you know what all the properties are and exactly what they say if ever you want to start doing proofs with these things. that is the next thing I'd like you to be able to do. I'd like you to be able to determine whether or not a set and a binary operation form a group or not. Right? So that involves, is this a binary operation at all? Are the other properties satisfied? Go down your list and say yes or no. Know what you're looking for. And last but not least, I'd like you to be able to start getting comfortable performing computations in non-standard groups.